Good morning, everyone. In the last session, we identified how this particular the client related example we identified, like we discussed about the discovery client as well as we identify the REST template and the Netflix phasing client. Okay, so these are all the three examples we identified in the last session. So today we are going to discuss about the another important example. Basically, so whenever we are trying to communicate with the multiple applications, so if the application is down, getting the point. So if the application is done, so now how we are going to communicate with this particular applications. So this particular example we are going to discuss here. So basically now what we can identify. So this is we'll call it as a client side resiliency patterns here. Getting the point. So client side everything we are going to configure. So when we are going to get any exception or if the application is not functioning properly, maybe if the application is responding with poorly or if the application is getting any exception, now what we will do, so in that case, so this particular section basically we'll call it as a the client resiliency pattern we are going to call. And here what we are going to do, so inside this particular client's resiliency pattern, so we are going to focus on the protecting the remote services. So basically with help of this particular resiliency pattern, we'll try to focus on the protecting the services. So what are the services? So either it is a microservice or any databases. So for example, we are having one service here, so something like service A, getting the point. So I'm trying to write service here. So this particular service, either it is going to communicate with the database, or it may be communicate with this particular so another microservices, or we can call it as a service B. So what happened basically when we are trying to communicate with this particular database, so the response maybe we can get poorly, or the response we are not going to get because of this particular database down or the database not functioning properly. Whenever we are trying to send in a request to this particular database, so we may not get any responses here. So in that case, now what we are going to do, and at the same time, so with help of this particular service A to service B, so yesterday we identified license service to organization service. Okay. So in that case, when we are trying to send a request from the license service to organization service, if the organization service is not returning any data, or the organization service is down, get independent, or we can call it as organization service is responding poorly. So in the three cases, now what we are going to do, so we are going to use the particular client side resiliencies here. So client side resiliencies we are going to implement with help of so other concepts, something like a circuit breaker pattern, and we are going to use the client side load balancing, and we are going to use the fallback method, and we are going to use the bulkheads. So these are all the different approaches we are going to use to handle this particular scenarios here. So when this particular applications are not functioning properly. Okay, so this particular, so when we are trying to handle this particular issues, we are going to call basically fail fast here. Getting the point. So this particular the goal, like when we are trying to not getting any responses, now what we will do with help of this particular load balancing, and with help of this particular circuit breaker pattern. Okay, circuit breaker. Now, so we can call it as a fallback, and the last one we can call it as a bulkheads. Okay, so these are all the very important section we need to identify. So using this, we are going to achieve the fail fast here. So fail fast basically, if anything is not responding, so we are going to get the expected message. So whatever we are going to configure, the particular messages we are going to expect here. So let's see how we are going to identify. So as I suggested, where exactly this particular sections, like this particular client side load balancing, circuit breaker, so fallback and bulkheads, where exactly so these sections are going to configure. Now if you observe carefully, so I'm having so request, like this is something like a web client. Okay, or we can identify it's like a microservice. So one microservice here, so something like a one service here. service here. Okay, now what I will do, so I'm going to send a request from the both locations. So these two locations we can send in a request either from the browser or we can send from the another microservices. So here first one, it is going to handle by the client side load balancing. Okay, so something like so simply I'm going to write client side load balancing CLB. Okay, so and later what happens internally, so it is going to another important section, it's going to identified by the so CB something like a circuit breaker, and below we can write the another important section called fallback, and the last section here we can identify something like bulkhead. Okay, so and if everything is go successful, now we are going to communicate so service B or service C something. But here it will try to identify the flow like this. After bulkhead pattern, so now it will go to the service B. If anything is failure, it will not hit into the this particular service B, or you are going to communicate any database or any another services here. Getting the point? So this is important. But so these are all the basic steps we are going to configure. Now what happens internally? Whenever we are trying to send in a request here, first it will identify whether this request having any cache related information. If the cache related information is available, it will try to return from the cache. So because client side load balancing basically, it will maintain the local cache here. Okay, if you are not having, now what happened here? It will try to come up with this particular circuit breaker. Now it is going to maintain some time here. So within that time, if you are getting the response, so it will try to return it will try to communicate with the appropriate microservices. Otherwise, it will try to kill the request. So whatever the request we are trying to hit into this particular service B, so it's going to take more than 10 milliseconds, or we can call it as a 10 seconds. Okay, so this particular request is taking more than 10 seconds. Now what happens internally? The request is going to kill here. So once the request is killed, now it will try to go for the any another information. Getting the point. So it is not opening, sorry. If the request is killed, it will go to the fallback. So inside the fallback, basically, we'll try to provide the alternative. So if this particular service is not functioning, so we are going to provide the alternative behavior. So the particular alternative behavior is going to identified by the this particular fallback. And so once it is identified, so we are going to communicate with help of this particular bulkhead with multiple so own thread pools here. Whenever we are trying to send a request here, it will try to come up with so its own thread pool here. So this is we are going to identify it. Now we'll identify how this particular section is going to work. Okay, so let's see. So we identify so where this particular the resiliency pattern is going to configure here. Okay, now we'll identify the client side. So whatever the client side I'm trying to explain here, basically the client side load balancing is going to involve so having the client to look up the service individually. So this is very important. Basically it is going to involve the one of the client side whenever whenever we are trying to send in a request from the browser, first request is going to receive by the this particular client side load balancing. Okay, now what it will do, so it will try to identify the physical location of the service instance. Getting the point. So where it is going to identify in the cache, it will try to identify the physical location of this particular service instance. So whenever the service, like whoever is trying to consume the service, now what happens internally? It will try to identify this particular client side load balancer, and it will try to return the physical location of this particular service from this particular pool. Okay, so client side is going to maintain some caching related pool here. So from the pool, it will try to return the physical location of this particular another service, like it's like a service B. So from the service here to web client, we are trying to communicate the service B. The service B, it will try to look up in the pool. So if the pool is not available, it will try to return, like it will try to communicate with the original service. So instead of loading the data from the cache like pool, it will try to communicate directly with the original request here. Okay, so this is going to perform, and now you can see, and if the service instance having any errors, or if the service instance, whatever the service instance we are trying to communicate, if it's trying to behave purely, getting the point. Now what it will do, it will try to remove it. The client-side load balancer, it will try to remove the particular service related information here. So where it is going to remove? In this particular pool, whatever the pool is going to maintain by this particular client-side load balancing, from the pool, it will try to return this particular service B related information here. So this is all about the client side load balancer. So simply we can identify, first it will going to communicate with this particular service B directly, and if it is expecting like whatever the time we are going to provide, if it's trying to respond more, then it will try to kill the request, and it will not going to save the data in the thread pool. Okay, and so if the service we are going to call the next time, it will try to communicate from the pool. If the service instant is available in the pool, it will return. Otherwise, again, it will go to the original call. So at the same time, if it is not responding within that time, so the service request is going to kill here. So instead of waiting the more time here, the service request is going to kill. So this is going to maintain by this particular load balancer. Now if I am going to discuss about the circuit breaker, so whatever the circuit breaker we are trying to define here, now what happens internally? So this is, you can identify in the software circuit, basically in our microservices, the circuit breaker, when the remote service is going to call, so either web client or service A, so these two sections we can call it as a remote service. Now what happens internally, the circuit breaker, it is going to monitor the call. So if this particular call is going to take long, now what happens internally, so here also the circuit breaker, it is going to kill the call. And in addition, the circuit breaker is going to monitor all the calls, whatever the calls we are going to receive from the remote services. Getting the point? And here, if I'm trying to get multiple calls, if I'm trying to get enough calls here, now what happens internally? So it is going to trip this particular circuit breaker. Now it will try to identify so do we have any the fallback methodology. If we are having the fallback, now it will go to the alternative here. So instead of waiting more time here, now what happens internally? It will go to the particular fallback, it will try to come up with the alternative related sections here. Okay, so this is, we are going to identify this particular circuit breaker here. So this is important because, so first it will try to identify some certain time here. So as I suggested, it's going to wait 10 seconds. So within the 10 seconds, if it is not identifying it, so the first request is going to kill it. So once this particular request is killed, now what happens internally? Again, if I'm going to get one more request here, getting the point. If I'm going to get one more request internally, so same request is going to waited by the same time here. Same time it is going to wait 9. At the same time is trying to receive the multiple calls. So within the 10 seconds of time, if I'm going to receive multiple calls, now what happens internally? So the circuit breaker is not going to give the option to communicate this particular service B. Getting the point, is not going to give the option to communicate this particular service B. So if you are going to provide this particular fallback, now it will try to provide the alternative. It will going to communicate this alternative here. Okay, so this is, we need to understand this particular circuit breaker. Now understand about the fallback processing here. So I just suggested, basically whenever we are going to get whenever the service B is going to get more time, so instead of throwing an exception, now what we are doing, basically we are trying to providing alternative code so that the alternative code is going to execute here. So those information we are going to provide inside this particular fallback here. Now, so we need to go for this particular bulkhead. So how exactly this particular bulkhead is going to implement. So if I want to understand this particular bulkhead pattern, so we are going to provide, if you are trying to develop any application, now what we will do, we'll try to So, like we'll try to implement the small pieces of code. Now, at the same pieces of code, we'll try to come up with the big application. So, simple example, how we are going to build the ships. So, basically, we'll try to divide the complete application into the so like different parts of the particular arguments here. Now, what we will do basically, so whenever we are trying to build each part of this particular shape, finally we'll try to we'll try to combine all the small parts into the one application here. At the same way, in our this particular bulkhead pattern, now what we will do basically, so we are going to interact with the multiple remote services. Getting the point. So whenever this particular bulkhead pattern is implemented, this particular bulkhead pattern, so we are going to use with the help of this particular multiple resources. So by using this pattern, now we can break this particular calls, whatever the multiple resource calls we are having, so we can break this particular calls into their own thread pool here. For example, this particular service B is trying to call multiple locations here. Okay, so instead of handling with one common pool, so instead of handling this particular one common pool, now what we will do, we'll try to divide into their own pool. So whenever we are sending a request here, the each request is going to contain the own thread pool here. So instead of containing the common pool, so this is going to so divided by this particular bulkhead pattern. Now what it will do, so once it is divided into their own, so we are going to have, we are trying to reduce the risk of this particular problem, because so if I'm trying to send the 10 requests here, so maybe 4 requests we are going to get an exception. The 6 request, so it is going to give the success messages here. So in place of common pool, now what happens? Even though the 6 requests are going to give the like a success message, but because of this particular common pool, so we may get some failure related exceptions here. So because of this, now this particular bulkhead pattern, what it will do, it will try to divide into their own thread pool, and it will try to reduce the risk of this particular application because of this particular own thread pool. So most of the cases, the data is trying to load from the thread pool. Okay, now what we need to understand here, so any thread, like any request here, which it is trying to throw an exception, the specific request only will fail, and the remaining the requests are going to success here. So this is the main behavior is going to identified by this particular bulkhead pattern here. Now here, so if you observe carefully, when the remote service is received into this particular appropriate service, now what happens internally, so at the same time it will try to assign the thread pool. If one service is responding slowly, now what happens is the thread pool of this particular one type of service will become stop here. Only whatever the service is responding slowly, the particular request service, the request relay service, it is going to stop processing here, and the remaining services, it's not going to depend on this particular service, and the remaining services basically it is not going to wait to complete this particular current service because of this particular their own thread pool, so they are not going to communicate with the other services here. So even though you are trying to send multiple requests here, so if this example, if this particular service 1 is trying to communicate with this service B, if it is functioning slowly, what happens internally, this service is going to remove from this particular thread pool, and the remaining services, if they are functioning properly, so they are trying to continue the getting the response from this particular service B. Okay, so this particular the pattern we are going to implement with the help of this particular bulkhead. So these are all the main important concepts we need to identify whenever we are going to discuss about the client side resiliency pattern. So if I'm trying to combine these all three, we are going to call up the client side resiliency patterns here. So this is very important information. So let me provide one more time. So this particular all the example how it is going to work. The first one, the client side load balancing. So it's like a CLB, the client side load balancing, what it will do basically. So basically it will maintain the pool related information. So how many services we are trying to communicate here. So each and every service information, it is going to maintain in the this particular pool here. So this particular pool basically it's like a client side load balancing. It's going to maintain the one like thread pool. So in the thread pool, it will try to have the each and every service information with a physical location of the service details. It's like a the full information about the service. Okay, if the particular service is trying to throw any error, now what happens internally? So the service is trying to perform slowly. The service is going to remove from the thread pool here. So whatever the thread pool is going to maintain by the client side load balancing, the client side load balancing, it is going to remove the service from the pool here. Okay, so this is going to identify by the this particular client side load balancing, and at the same time the circuit breaker basically it will try to maintain the time. So it will try to maintain the time. So when the time deadline is reached here, so it will try to kill it will try to kill the whatever the request we received here. So instead of waiting the time here, instead of waiting the more time, basically what it will do, so it is not going to give the option to respond. It's not going to wait more time to get the response from the my dependent services here. So what it will do, it will try to kill the request here. So this is, so it's going to identify by the circuit breaker. So fallback basically it's like a alternative. Instead of throwing an exception, it will try to go for the alternative code. So wherever we are going to implement the method information we need to provide so that the alternative code is going to execute it here. And if we observe this particular bulkhead pattern, whenever we are going to have multiple requests, so each request is going to identify by their own thread pool. So when any request is failed, the appropriate request is going to fail and it is not going to depended with another pool sections here. So this is the behavior of this particular client side resiliency pattern. So if I want to understand more information about this, now we'll identify so with one more diagram so that we can easily identify how the real-time scenarios is going to fail here. So observe carefully. Let me clear this particular diagram now. So we are going to provide this particular informations with help of this particular services here. Now we are having application, so applications A. So something like this is the application A and this is the application B. Now imagine these two applications we are trying to communicate them with the service here. So here I am trying to add service here. Okay. Here I'm trying to add this particular service here. Now internally, so internally this service here, it will try to communicate with the database. Okay. Internally it will try to communicate this particular database to retrieve the data from the database. Now, so once the data is retrieved, now what happens internally? It will try to call based on this particular database response, it will going to call the service B. Okay. It is going to call the service B. Getting the point. Now, so whenever the service B is going to call here, so completely, basically it is a different data forms. Now observe carefully. Now what happens internally? So it will try to come up with a complete database here. Whenever the service B, so when we are trying to use the data from the complete different to database, now what happens internally? It will try to communicate with another service. Basically, this is not in the scope of this particular service B. Because the service B internally, so it is not using the whatever the service A database is identified here. So the service B, it will try to come up with another database. So it will try to communicate with another database. Now you can see what happens internally. So this is the out of the another service. There is no scope within this particular service way. So once the data is received from the database, now we are trying to send the request to the service B, and the service B, it will try to communicating this particular database here. So from this particular database, now what happens internally? If you are trying to communicate any the third part service related section, so it's like a service C. Getting the point. So it's like a service C. So service B now internally communicating the service A. Okay. So now observe service C. So this is the basically the third party, now we are going to communicate through the cloud. So this is important here. Now what we are doing is, so service A and service A not in the cloud, these are in the server. Now, so if I want to communicate this particular service A, so I want to communicate through the cloud environments here. So what happens basically, so if I want to communicate this, basically we need a network related information. Okay, so we are going to write some network information, then only we are going to communicate this particular service C. So now the problem basically, whenever we are trying to communicate this particular service C from the service B here. So sometimes what happens is, because of the cloud is down or the service application C is down, so we cannot communicate the service C here. So whenever we are not communicating properly with the service B, because service A is depending on service B and the service B internally it is depending on this particular service A. So what happens internally? The whole application is going to wait. Getting the point? The whole application is going to wait here. So this is the main drawbacks we are going to have here. So now if you observe here, somewhere if I'm trying to implement the client side load balancing, circuit breaker, the fallback and everything, now what happens internally? So if you wait a certain time here, if the response we are not getting it, so directly it will kill the request here. So whenever the request is killed, we are going to provide the appropriate response message to the service B. So the same service B, it will try to provide the same response to this particular service A. So instead of waiting more time here. So this is basically we are going to identify the drawbacks here. So with the help of this particular patterns, we can identify the issue and we can implement the wherever we are going to have this particular problems here. Now, so what happens internally? So basically the service C entirely it is different from the service A and service B. Getting the point? So directly if I want to call this particular service B, so we can call from the application C. Getting the point? It's like a third party application. So this particular application nowadays, we are trying to communicate lot of applications. It's like a payment application. One of the example, payment application. Any e-commerce application. So up to these services will be in the single applications. And whenever we are trying to make any payment, we are going to communicate with so third party services here. So nowadays, each and every application they are trying to communicating third-party applications. So to get the appropriate responses, any banking applications or any or finance related, e-commerce related, so they are going to communicate with the banking related applications, or you can say the some UPI related applications here. Okay, so now we identified here. Now, how we are going to implement this particular section here. So if I'm going to add the circuit breaker, now what happens internally? So it's going to wait some time here. So here we can implement the particular the circuit breaker related concepts here. Okay, or if you are interested, here also we can make, and here also you can provide the same information here. So in the database level, if the database not functioning within that time, so we can send the responses here. So same database level as well as whenever we are trying to communicate with another services. So if you are interested, here also we can provide the particular pattern related sections here. Okay, so this is the main important information we need to identify here. Now, so if I'm going to implement this particular the circuit breaker related concept, now what we need to import some libraries. So what are the libraries we need to import? So here we need to import this particular high stack related libraries here. So this high stack basically it is going to have this whatever the as of now we discuss here the particular patterns. So library information here. So now I need to download this particular high stack related information and we can start the implementing on this particular sections here. So let's run this particular example after adding this particular properties here. So if I want to add this particular properties, now what we need, so again we'll go to the license service here. So inside the license service, now I'm going to add sections here. Go to the Maven repository, and inside the Maven repository, so we need to add Netflix. Let me copy. Starter high stick. Let's see, do we have any starter? So we need to use this particular Netflix sticks here. Okay, so now just I will add here. I'm not going to save the changes, and we don't need any subversion also. Now what I will do, so whenever we are trying to add this particular sections code, so first after adding these two dependencies, first we need to identify the main file. Here I'm going to check the another important section call. So whether do we have this particular circuit breaker. So you can see it is deprecated. So when from the which version onwards it is deprecated. So circuit breaker import section. This is implemented in the which version? So they given order this. So now you can see if I want to enable this, basically is expecting to add a property spring.cloud.circuit.breaker.enable. So based on this particular property, now it will enable here. So otherwise it will not enable this particular circuit breaker. So this is expecting to on this particular property. So now we'll try this after saving this particular section of code. Now I'm trying to refresh this. So we need to add this particular stick related section. Okay, now it could not load the repository. So we need to take that from the Google, because what is the current version? Why it is not loading from the hashtags? Maybe the group ID or artifact ID may be changed here. So we need to identify. So we can identify in the Google with the help of this particular latest changes. So it is not this. So whatever we provided, ORG, Spring Framework Cloud, Spring Framework Starter Netflix. So same thing we provided. Yes. So we are also having the same one. We'll see. Okay, maybe we should also specify the versions here. Okay, if I want to specify the version, here we can add. Okay, so it is not identifying this. Now, what is the message we are getting? So provided vulnerability dependencies, Google dot. Okay. Uh, Okay, so basically the dependency we are getting some vulnerability. Now, so we'll ignore this. Now you can see we are able to import this. So maybe, so this is expecting the version. So now we added, let me refresh one more time. Okay, so all the dependencies are reloaded here. Now we'll identify this. So let me go to the license service application. So here we can add. So enable. Okay. So anyway, it is getting the same. Now we are getting this particular. Let's see. So why I'm getting this deprecated. So this is also we need to identify here. Two dot 5.12 and suggest a replacement. Oh, nothing is there. ENV, should I still use iStick on the new project? So now we are using the Netflix high text only. The main difference is use the circuit breaker libraries. Maybe whatever we are using here, resiliency 4, they are trying to suggest here. Not available after. Okay. So what is the cloud version we are using? Maybe because of this, then the cloud version it is not using, I guess. Okay, so 2021 we are using. So because of this here you can see, so they are trying to suggest it. So after the 2020, it is not supporting this. And we can go for this particular resiliency sections here. Now understand here, cloud Netflix here. After this, whatever we are having, Erica server. So Netflix has fixed the remote here. Joule. Okay. So what is the another version they suggested? Maybe. So we need to go to this now. Greenwich RCY. Okay. Let me copy this. Just to choose the second because. So how they are trying to implement this? So start a resiliency. Okay. So they are trying to work with the resiliency 4 only. Now we need to also implement same sections here. So this is the resiliency concepts here. Backend service documentation. Okay, so let me copy the. So first we'll identify whether we can access or not. So if we are able to access, we'll keep. Otherwise, we need to change this particular library. So library is now changed to the, instead of using this particular high sticks, so they come up with a different section. Now, so we'll try to use this. Where is a license service? So I'm trying to use this particular example. So we'll see. So basically, what is the starter we are adding? Basically, it will try to download the this particular high-sec libraries here. So if I want to download the high-sec libraries, now we need to use this particular dependency here. So after adding this particular section, now what we can do, we are going to add this particular circuit breaker annotations here, and after this we'll try to provide the So information. So basically, first we'll try to discuss about the database, and later we can communicate with our organization service. So if I want to communicate with the database now, what we need? So we need to add the one more annotation. So I'm going to discuss about the controller class, organization ID, and license ID. So this particular method, I'm going to come up with a hashtag command here. Now here I'm going to add the, so this is the command we are going to use. So any command, like if I want to follow the any pattern, so it's going to start with this particular hashtag command. Now, so inside this particular hashtag command, we are going to provide the different properties. If I'm trying to give this control space, so you can see these are all the different properties we are having. So here you can see one of the fallback method, and here we are going to discuss about the some thread pool related. So this thread pool related sections will comes under the bulkhead pattern. Okay, and the same way, so here we are trying to providing the time here. So ignore exceptions, group keys, so default fallback and command properties. The command properties basically it will comes under the circuit breaker. So all each and every pattern if I want to discuss, first we need to add the annotation called hashtag command. Okay, so basically the hashtag command is going to this is the root command basically. Now internally, if I'm not providing any values by the default values whatever we are having, it will try to identify here. Okay, so now we'll see so how it is going to execute this. So if I want to provide the hashtag command here, so here we can identify the default sections here. So default empty, so command key also empty, so fallback method also empty, and something like exceptions. So as of now defaults are empty, so default fallback method is also empty here. And these are all the default related exceptions. So now we can write the ignore exception. If you are trying to ignore the specific exception, basically we can ignore this particular exception by adding this particular ignore exception. So it's like the variable name here. Now we'll identify so how it is going to work this particular hashtag command here. So this is the simple one we are going to add. Now go to the services. So try to run all the services here. So first I'm trying to run the Erico service, and later we are going to run with a configuration service. Okay, so configuration service is running, and at the same time started Erico server also. Okay, finally now I'm going to run license service. So some exception we are getting here. So organization fees and client. Okay, so maybe we commented this. So maybe we commented this, because of this it is trying to throw an exception. Let me debug one more time. Okay, so here you can see, so license service also started. and later we can start this organization. So right now it is not important here, but now what we are doing here, basically we'll go to the postman, and we'll try to enable the our database. So we need to see the data. So what is the data we provided here? And docker it is not required, we can close this. Okay, so go to the license service. What we are trying to use is, so this is organization ID and license ID. Now if I'm trying to hit this, now we can see, so we are able to see the data. So the data we are able to see from the database here. Now if you want to understand here, inside the license service we are able to see the select statement. Now what I'm trying to do here, so inside this particular license service, whatever the method we implemented here, now the get license method we are going to modify here. So how we are going to modify here, this is important here. I'm going to call this is the what we can, let me, so here we are adding the comment iStick command. Now inside this particular iStick command, basically now what I will do, before going to run this, I want to write one method. Here I need to implement this particular method. So this particular method, basically what we can write, basically it's going to throw an exception. So I'm trying to wait more than the default time here. It's like running. So randomly running here. So this is the method I'm trying to implement here. And this randomly running method, before calling the organization ID, it is going to load here. Now, so if we observe this particular randomly running method, what it will do, basically, it will try to organization client dot okay, so here we can write the implementation of this. So random class, random is equals to new random, and here I'm now what I'm doing here, if this particular random dot next int, and okay, here I can provide the value. So the value, basically, so 3 minus 1, it's become 2, and after this I'm trying to add with the 1, and so here I'm going to add with the 1. So this is the random value I'm trying to selecting here, and into what we can identify, random number. Okay, so if this particular random number so equals to 3, now I'm going to call one sleep method. So sleep method also I'm going to implement here. Okay, this is the sleep method. So inside this particular sleep method, now I'm going to call thread dot sleep. So around 12,000 milliseconds time I'm trying to provide. Handle the exception with the try catch block. So this is the method. Now if you see what we are doing basically, whenever I'm trying to call this particular get license, internally I'm calling whatever the current thread we are having. So I'm going to send in a waiting state here. So this is the waiting state. So this is we already discussed it, thread dot sleep. So based on this particular milliseconds time, it will wait here. Okay. Now we need to identify how this particular example it is going to work here. So now observe. Let me restart this particular license service. So reload. Okay, so we can see application is started. Now I'm going to clear all. So again, I'm trying to send a request. So maybe we'll put a breakpoint here, whether it is calling or not. Now it is calling. Okay, so random we are getting as a 2. Okay, because of this it is failing. So because random 3, whenever we are having, we are expecting here. So now you can see we are getting the exception. So if you read this exception, timeout exception. So timeout exception we are getting basically, this is trying to load from the where. So extract related exception only we are getting. So now you can see handle timeout via fallback. But we need to see the messages also. So whatever we are trying to providing here, internal server. So this is the exception message. I checked timeout. Let me run one more time. Okay, so here we are having breakpoint. Let me remove this. So this is also same, I think. Yes. So timeout exception, because within the time we are not providing, because of this, now we are getting this particular exception. So whenever the time is completed, now what we can do, instead of throwing this particular exception, we can go for the some different the fallback method section. Let's see, I'm not providing anything. So now you can see successfully we are getting the data. So now also we are getting the data. So this time we are getting an exception because the criteria is matching. So whenever the criteria is matching, now it is throwing in a exception. So because whatever the time we provided, it is more than the specified time. So you can see, so we are getting like we are trying to wait around 12 seconds. But what is the minimum time? Within the 10 seconds. If the response is not coming within the 10 seconds, so it is going to throw in a exception. So this is the circuit breaker is going to handle here. Because of this particular annotation, whatever we are providing is circuit breaker, now it is functioning properly. Okay, now what we can do, instead of writing this particular method, now I want to come up with so different messages basically. So now where I'm trying to providing the message, so I want to provide the message so that we can identify. Okay, so let's see, we identify the path and exception we are able to see. Here this is the path it is providing. Whatever the path we are trying to access here, this is the path, and the error we are getting here, basically it should return the error message also. But the error message if I want to return, we need to construct the exception class here. So we need to construct the proper exception class so that we can get the appropriate exceptions here. Okay, so anyway, now what we are going to do here, we are trying to providing so another important information. So now we identify within the time if I'm not providing, So it's going to throw an exception, something like a high stick related exception. Now, what I will do here, I'm going to provide the customization. Getting the point. So here I'm going to provide the customization. Instead of providing this particular 10 seconds, now I want to provide the some additional time. So how we can provide this particular additional time here? Now here you can click on this. So what is the property we can select is, so command properties. Here you can see the command properties we need to identify. So we can select this particular command properties here. So inside this particular command properties, so is expecting multiple values. Again, I want to provide a high stick property. So this is the high stick property we are going to use here. Now, the high stick property basically anything, nothing. Is expecting the name and value. So name, what is the name of this particular property? Here I can write here name section. Name is equals to, because it is a string, so we can provide the name. Let's see whether whatever I'm having, the name is same or it is modified. We need to identify. So something like execution dot isolation dot thread dot so timeout in milliseconds. Okay, so this is the name. So value also is expecting string here. So we can give, so 15,000, like 15 seconds. So 15 the seconds I'm trying to give this particular time. Now after this, so now what we can do, we can run the same example. So even though we are trying to wait within the 12 seconds here, but what is the time I given? So 15 seconds of time I given here. So we cannot get any exceptions here. So successfully it needs to handle this particular whatever the data we are trying to load from the database here. Okay, so license service is started. Now I'm clear this. So again, I'm going to send in a request here. So now first time we are getting, so second time we are getting, third time we are getting. Now you can see, so how much the fast we are getting this. Now if you see, this is taking some time. Why? Anything is failing? Nothing, right? So here also we are getting the same. But here, why it is expecting this much time? Disable false, so status is respond. Maybe some it is related to the discovery client related logger we are able to see here. But now you can see finally we are getting the data. So we are not getting any exceptions, even though the data, like even though we are trying to sleep here. Now you can see every time we are getting the data, we are not getting any exception, because so we given the different time as a 15 seconds. So default time we replaced it with this particular 15 seconds here. So this is, we need to understand very clearly here. So this is all about the circuit breaker. So if it, now we'll come back to the another properties whatever we are having here. So now we'll go for the fallback method. So if I want to go for the fallback method, now what we can do, so here we can write the inside this particular command. Here we can try to write the so fallback method. This is the fallback method. Basically we can type the name of the method. Here we can write the particular method here. So what is an object we are trying to return? Basically we are trying to return the license. So instead of returning this particular license, now what we can do, build so fallback license object. available. Okay. Now what I will do, so here I'm going to provide the method here. You can make a private here because this method internally it will call for the our circuit breaker. So I'm going to write the same method. Method name should be same here. Now, so whatever we added in the license controller, I will copy this. Here I will paste here. So now I'm going to provide the messages here. So license ID. License ID, we can make something. Okay, so organization ID also we need to specify zeros because basically product name. So just for understanding, I'm trying to write fallback. So license type is basically so high stack. Okay, so this is the message we are going to provide here. Right. So now if I want to provide any additional message, you can provide the additional message. So something like if I want to provide the license dot so product name. So inside this particular product name, sorry, so just we can write to no license information is no license information currently available. Okay, so this is a message. Now what I will do here, now here what we can do, so basically we'll try to provide this particular sections here. Where is running? Instead of 12, so default time is 15 seconds. Now I'm trying to providing so 22 here. So instead of getting an exception, now we need to see this particular license object. So because here now we are trying to configure the fallback functionality here. Let me rerun this particular service here. So reload this. License service is implemented. Now I'm trying to send a request here. So let's see. So again we are getting. Okay, so method is not found. Okay, maybe is expecting two parameters. So you can see build fallback license is expecting string comma string, but we could not provide the two method related section. So it is a default method. Okay, so this is we need to identify here. Now I want to provide these two sections. String organization ID and license ID. If you are having the organization ID, directly we can provide, and license ID we can provide here. Okay, so now I'm going to rerun the same method. Sorry, rerun the same applications here. Now we'll identify. So currently it is running. Now we are getting the data. So here you can see we are getting the data. Now we need to identify the condition should satisfy here. Whenever the condition is satisfied, now what we need to get here, whatever the default object we are trying to return, the particular default object we need to return here. Now you can see, sorry, no license information currently available. Getting the point. So whatever the message we provided here, the particular message is getting here. So this is an ID and this is the organization ID. We provided the particular license type here. Okay, so this is the way of implementing the fallback. Now what you understanding is, so here we are getting an exception like so now it is satisfied this particular randomly condition. Now it is going to this particular sleep. Getting the point. So once it is went to this particular sleep, instead of throwing an exception, now right now what we are doing is we are returning this particular default object. Okay, so this is the way of implementing. Instead of waiting multiple times, now instead of waiting more than the specified time, what we are doing is, so it is calling this method, it is returning this particular object. So this is the way of implementing it. Now we need to identify the another important section called the bulkhead pattern. So whatever we identified here, so now we are identified the circuit breaker. Now we identify the fallback. Now we are moving into the important section called the bulkhead pattern. Now what happens internally? So whenever we are trying to implement this particular microservice based applications here, so we need to call the multiple microservices. So that we are discussed here. So because so we could not identify how many calls we are going to call here because of this particular microservices. We'll try to communicate to each and every service independently or dependently here. Okay. Now what we will do? So without this particular bulkhead pattern, now we identify the how it is going to provide the information. So it's going to provide the same thread information. Okay, the same thread pool information it is going to provide to the all the requests. Yes. Okay. How many requests we are going to receive to this particular microservices, all the requests is going to return the same. So instead of doing this, now what we are doing is we are trying to providing so separate pool information here. Whatever this particular threads information, so each request we are going to create the each thread pool information here. If it is only one, now what happens internally? So the sometimes here the container, so it's going to crash here because of this particular request. So you cannot imagine. So if you are going to send more than 100 requests, so if 100 requests are having same thread pool, so definitely the application is going to be crash here. So because of this, now what we are doing here, for each request we are going to maintain the separate thread pool here. So how we are going to maintain this? So by default we can maintain the like 10 thread pool or 100 thread pool. So we can specify the size. Based on that, it will try to maintain the thread pool here. So from this particular thread pool, it will try to communicate the requests here. Getting the point. So it's basically it is simple. So it's now if you see, we are going to call the request here. Okay, so these are all the requests. And internally here we are going to maintain the thread pool objects here. So these are all the thread pool objects. So from here, it will try to communicate with our microservices here. So how many microservices? So either you can go for this is the database, and this is we can call is the microservice A, and we can go for the microservice B. Everything, this three is going to handle with help of this particular thread pool objects here. So this is the main advantage we are going to get with the help of this particular bulkhead patterns here. Now, so we'll identify how it is going to, how we are going to implement this particular section of code. So let's see. To understand this, first we need to provide the thread pool key. So here only I'm trying to providing it, and after this particular fallback, default it is not providing any name here. Now our customization, so we need to provide the thread pool. So something like what is the method we are calling license object, right? So we can provide the same key. So license by organization. So this is the license by organization thread pool key. And now, so what we can provide here, so another important section, so thread pool properties here. So this is the thread pool properties. Now internally is expecting array type. Array type basically it is a multiple values. Now here you can see we can provide the so same property, so name and value. Whatever we identify the high stake property. So here we could provide the name. The name basically core size. So value. So we can provide the so basically this is the size of this particular threads pool, and for each request it's going to occupy the so this particular 10 here. Now let me add here. Now I'm going to provide the so I stick property name, so something like max value 10 here. So this is the information. This section entirely is providing the information regarding the bulkhead pattern. So this is something like the fallback, and this is we identify the circuit breaker here. Okay, so these are all the information we are providing here. Now, so basically what we are doing here, so this is important here. So first we are providing the thread pool key, and later we are trying to providing the core size. So basically what happened in this particular core size, it is going to use it to control the behavior of this particular thread pool. Getting the point. And now how many thread pool size we are setting here? So it's like a 30 we are setting here, and after this we are trying to move on to the max queue size. So what happens internally, we are trying to set up this particular queue related. Basically how many uh, threads we can make as a queue. So at each request we can make as a thread like a 10 threads as a queue here. So this is we can increase based on this particular core size. So core size, if you are not interested to this particular 30, you can make as a 300 or 400 something based on our requirement. So from the core size we are going to make something like queues here. So it's like they are going to wait in the something like we can give the some threads to wait. So the threads we are giving as a 10 here. This particular 10 set we can make as a queue. So once this particular 10 threads are completed, now another more 10 threads are going to come into the queue stage here. So this is it is indicating this particular max queue size here. Okay, so this is the main information we need to understand here. So after this, now what we will do, we'll try to identify the same example one more time. So once it is built here, we can restart the application. Now you can see, so this is the license service is turning. Now I'm going to send in a request. So you can see we are not going to get any exceptions here. So even though if it is waiting more time here, so it will try to come up with this particular thread pool, and it will try to create the objects whenever the exception is failed. Now you can see, so sorry, we don't have information, but we are not going to get any exceptions here. What is the advantage we are going to get basically whenever I am trying to add this particular thread pool section? So now if you can see, if the code size of this particular thread pool is busy, now what happens internally? So we are giving an option to, if we are going to get any request, so those requests are going to be in the waiting state basically. So how many requests we are making into the waiting stage? The particular 10 requests we are going to make in the waiting stage. So this is indicating this is the max queue size here. So this is all about the basic information about the all about the client-side resiliency pattern we discuss here. Okay, so any questions on this? So all the three patterns we identified here. Okay, so this is we are getting. Now if you understand more about this particular keys here, so in the cloud section, here we need to identify the strict where we are having high strict. See, this particular pattern we can go for the databases and when we are trying to use the third-party APIs. So if you observe, this is now we implemented with help of this particular get license here. So now if you're not interested, basically what you can do, so whatever we implemented yesterday, randomly get license, this method. So here also we can provide, so find by ID, so with organization ID. Here also we can implement here. The same method now I'm trying to implement on top of this particular organization. So this organization basically we are communicating with the organization application. So we are going to return the data. Now if I want to send this, now what I will do, so we'll restart the same application. Now we'll try to hit the same request, not same request here. So most probably yesterday we tried this one. So this request we are going to hit. So let's see the license service ID is same or different. To understand, first we need to start the Eruka. Where is the Eruka? So 8761. So this is a license service. Okay, so once the license service is started, now we'll send. So if you observe carefully, I'm not starting the organization service. So directly I'm sending the request here. So whenever we are sending this request here, what happens here? So he's expecting three parameters. Now you can see he's expecting three parameters. So earlier, whatever we build here, so that is a two parameters. Now we are calling on the three parameters method. So now copy the same method. So now I'm going to pass the three parameters here. Okay, so license and here we can write organization. So organization information currently is not available. So this is object I'm trying to build here. Now let me rerun this. And so meantime, now I want to provide the in the Spring Cloud documentation. There is such. So I want to identify the properties. We are going to have a lot of different properties here. Anything we are able to see? Batch, graphical, security. Good, sir. Okay, I will let you know. So because we are going to come up with different properties, so those properties I need to figure it out. So in the documentation, so where we can use. Now, the same request I'm sending. Now you can see. So sorry, no license and organization information currently available. So why we are getting basically this? Because of this particular uh, organization is not running. So every time if I'm going to send the same request here, so we'll get the same message. Now you can see the message every time we are getting because of this particular organization is not running. Getting the point. So if I'm going to run this organization, now what happens internally? We can load the data from the organization service and we can return this particular data. So now we'll see how this particular data is going to load. Okay, organization service is running. Maybe time is not license is loading. Okay, organization service is failing. So load balancer does not contain the instance of this particular organization service. So maybe it has changed or something. We removed anything. So which section we are discussing is so Phison only, right? Now why it is failing? It should be the client to type. So I'm going to put a breakpoint. Now we'll see. So this is false and this is also false. Okay, so this is satisfying here. Organization service only, right? So why it is failing? Now it is working as expected here. Uh, Now it's also failing. So this trying to select the statement after maybe, so because of this time I guess, let me modify the time. License service where we are implementing this. So 25 seconds I given the time. Okay, so now it is started license service. Let's send in a request here. Okay, so I think it is failed. Let me click on this. Now you can see it is loading. Maybe earlier because of the milliseconds of time it is failed here, but right now we are able to see this particular data. Now here you can see license service is generating and organization service also generating here. Now if I'm going to run one more time, so if it is within the time, so I'm trying to wait some time here, so it is satisfying this. Now it will go to the this particular section, so I'm going to wait here, so a couple of seconds here. So after this we can hit this. We'll see what happens internally, how it is going to send a request. Now also we are getting. So we need to wait a few more seconds. Organization is null. Now I'm sending. Okay. So even though site is trying to load the same data here. Code size 30. Okay, so if I want to implement again, I need to come up with the randomly running method. So here also, so that we can check. So how this particular fallback method is calling. We already identified. So this message we are able to see on our postman here. Okay, so this is the implementation of this particular three sections. These are all the very important section we discuss in the today session. So tomorrow, another important section we are going to discuss here. So it's like a gateway related sections we are going to discuss here. So how the gateway related is example is going to work, and so basically whatever we identified in the today session, so iStick is going to support on the 2021 libraries because they come up with the deprecations. So now if you want to understand, so we need to go to the, so this is the resilience 4 we need to use here, the 4J. So I will identify with a simple example how it is going to work. So we'll identify later, and tomorrow we are going to communicate with the first gateway related section. So later we are going to discuss about the security. So these are all the two sessions are pending. So once these two sessions are pending, so we are close to the microservices sections here. Okay, so using this particular whatever we implemented, so try to build a small applications here. Now how we are building a license service, organization service, same way. So you can create, you can imagine one any like applications, either the bank applications or e-commerce application, anything. So just come up with the different services and you can build the applications here. Okay, so this is the way of building the microservices applications. Any questions regarding our today's session? Okay, so if we don't have anything, so tomorrow we'll continue.